Hey everybody, welcome to the first Earth and Space Cyber class. It will certainly not be the last, but hopefully we do get back and do this stuff live for each other. So we haven't finished up the atmosphere yet. Have a few things with pressure, and we'll talk about wind. Then we have some fun subjects regarding storms and hurricanes and tornadoes. And then after that, we'll probably end up heading towards things about the sun and some of the planets before the end of the year. But this first one, atmospheric pressure. What is it? It's the force exerted on the surface by the weight of the air above that surface. So, in the room that you're in right now, watching this video, there's air all around you and it has weight, and gravity's pulling it down, and that weight is actually pressing on the ground. And there's air above us, all the way up to the thermosphere, way up, and all that air adds up and has a lot of weight pushing down. So 99% of the total mass of the atmospheric gases is found within 32 kilometers of the surface. And if you know from what we learned about all the mesosphere, thermosphere, it's pretty much all the way up to the top of the thermosphere. Beyond that, there's a vacuum. There's no air or any molecules at all. It's a total vacuum. All right, so for 1 centimeter column of air, you can put your fingers close together. See how big a centimeter is, but the width of your finger. At sea level, has a mass of 1 kilogram or 2 pounds. If you want to go in inches, it's 14.7 pounds per square inch at sea level over your entire body. Now, over the whole surface of your body, there are about 19 tons of pressure pushing on you. And you're probably thinking, well, how am I holding all that up? Well, it's a balanced force. The pressure is coming down, it's coming up, it's equal in all directions so you don't feel it. But it's there. It decreases with altitude, of course. As the higher you go, the less the pressure. And here's a good visual of seeing what the column of air looks like. At the very bottom here, you can see a lot more air molecules packed together. They're moving around. And as you go further and further up, they thin out. So that's why, if you're climbing Mount Everest, you go up to 35,000 feet, you're barely breathing, you need an oxygen tank to continue with the hike. Air pressure is equal in all directions, like I said earlier. That's why you don't feel these 19 tons of pressure. It's pushing up, it's pushing left, it's pushing right, down, every direction. It's also on the inside of your body pushing out, so it's all equalized, so you don't notice it. And it's dependent upon the density of the air. So there are times of the year or with different kind of weather, where it varies somewhat. Hotter air is less dense. The air particles are moving faster, so there's more room between them. That's why baseballs, during baseball season, more home runs in the middle of summer, July, August, than there are in the cooler weather. There's less air for the ball to travel through. All right, measuring the pressure. Units measured are inches or millibars. 1 inch of mercury is equal to 33.86 millibars. And, you're probably thinking, well, what's a mercury? Well, we'll get to that in a minute. Standard sea level pressure is 29.92 inches or 1,013 millibars. So if you're standing right down, with your toes are in the water down at the beach in Jersey Shore, the standard level pressure is 29.92 inches of mercury. Again, we'll get to that is later. And again, the weather will change that. There'll be high pressure, low pressure systems above you. That'll change the pressure a little bit. You guys know about that now from the test you did or the measurements you have taken. Collected that data of all those different 5 cities. You saw that changed over time. But they pick a number just to say it's a standard. The highest ever recorded was 32.06 and the lowest is 25.69. And the highest is usually going to be during fair weather, which we'll get to in a moment. And the lowest is always during some kind of bad weather. Typically a hurricane will have that kind of a low pressure. All right, factors affect air pressure. Density. Temperature. Warmer the air is less dense. So again, summertime, air is less dense. In fact, I know that some planes, when they leave Phoenix, Arizona, and it's 120 degrees, they need longer runway and get more speed so they get the plane off the ground because there's less air to actually lift the plane up. Water vapor. Large amounts of vapor cause low air pressure. So again, in the middle of summer, there's a lot of humidity around. It takes away from the place for the air particles to be. So again, less pressure there. And of course, the higher you go, the less pressure. You just drive around Berks County, you go top of a mountain, up near Hamburg, perhaps, or on Price Town down here closer to Reading. You go up the hill, you'll hear your ears pop, or come back down, you can feel them kind of fill up. The air's thinner the higher you go up, less pressure. You feel it in your eardrums mostly. Types of air pressure. There are high pressure systems. Now I'm talking about weather. High pressure systems, cool, dry air. So you get some of those even, when you get a front come through, the skies get blue, clear up, it gets kind of cold. That's a high pressure. They rotate clockwise. So wherever that high pressure system is centered, the air spins around clockwise. And it was usually sunny and clear. So if you look on the left-hand side, that's a high pressure system. It's spinning clockwise. The air goes around it. So if you're on the surface to the north of that, the wind will be blowing from the west. Or if you're on the east side of that, the wind's kind of coming down from the north. And then low pressure, warmer, humid air, and they rotate counterclockwise and usually involve some inclement weather, rain, storms, hurricane. And they spin counterclockwise. And when these two systems are together, they work together to give you combined wind. Since the low's pushing down on this side, the high's pressing down on this side, you get a very windy condition in between. So you may notice after a rainstorm goes by, usually we have a day or two of higher winds. That's what's happening between the high and low pressure systems. All right. Now, how do we measure pressure? Is through an instrument called a barometer. As I said earlier about mercury, a barometer is made of a tube of mercury, and it's a vacuum top. The closed off. It's like an upside down test tube, and it's in a pool of mercury. And it's chosen because of its weight and density. It's a very dense material. It works well with making measurements on a smaller scale, but mercury is kind of expensive, so it's not always convenient to use. And as the air is pushing down on the open part of the mercury down below, it'll push up the mercury inside, giving a higher pressure. And the pressure is lower on the outside. The mercury will rise here on the outside going up, and then the level inside the tube will come back down. Hang on here. So again, the mercurial barometer is the mercury. It consists of a glass column standing in a well of mercury. The air pushes down, pushes the mercury up, and vice versa. Again, mercury is chosen because of its density. You can use water or alcohol or other kind of liquids, but the mercury, because of its density, gives you a stable reading. The aneroid is the most popular type. You probably have one hanging in your living room. It consists of a sealed metal can, which is this part over here. It has no air in it. And as the air pressure changes, this acts like an accordion. It goes up and down. This can goes up and down, and it pushes the needle over the meter there to show you whether the pressure is going up or down. So those are the most common types. So you probably have one of these hanging around. I know I do. And that shows the inside of it. One last thing here is an altimeter. Measures the altitude based on change of air pressure. So on airlines, planes are flying around. Not so much these days because of the COVID-19, but when planes are flying, they set a certain pressure based upon the weather. And as the airplane rises, as it's going up in altitude, of course there's less pressure around, and they can use that setting to actually adjust, and they can tell the pilot how high they are. There are two assignments to work on for atmospheric pressure, and they're in the Google Classroom. First one's called Leaking Tank. So you click on that, and it'll show you a picture. You have to go to CK12 group. You may have to log into this using your Google password. So when you get a choice to log in, you can see left of the screen it says sign in with Google. I have to do it here anyway, which is just great, so I can show you. So sign with Google. Come on. And then you'll enter your Google. It looks like it got me anyway. So you might have to sign in, but it's not a big deal to get in there. And then this thing called leaking tank. So what you have here is a large water tank, and it has a little leak coming out of it. That's why it's called leaking tank. And you can drag this red button up and down. Now what you can see happening is there's a stream of water leaking out. And the further down you go, the further it shoots out. The higher you go, the less it shoots out horizontally. And you can probably imagine why, because the pressure is lower at the top and higher at the bottom. Okay, so what I would like you to do is play around with it a little bit. It tells you how far the distance from the container is just below the tank itself. And on the left, it explains what little story of what's happening. And then I'd like you to try the challenge me button here at the bottom left. Hit that. A couple easy questions for you to do. I've assigned this as an assignment. Doesn't take much to do. If you get them wrong, it's okay. Don't sweat it. I just want you to play around with this a little bit to see what happens with the pressure in this column of a fluid. Now, air, we live in air, not water, but air and water are both considered fluids. They act the same. So this has the same idea as air as water. That's why this will work for you. The other one I got for you, here's a picture of high and low, and you can kind of please leave it on northern hemisphere. That's where I live. And you can drag this around and get it to look kind of like the picture I had in the notes, and you can kind of see how the air is pushed outwards for the high pressure, inward for the low. And what's kind of cool also is you can kind of spin it around to see it from the side. I can't get this thing to go the way I want it to. Hang on, here we go. You can see what's happening. And the air is coming down at the high pressure on the left and going up in the low pressure. Now, I have a few questions based upon this picture for you. That's the next Google Doc. A couple questions. Answer those and submit those to me as well. All right, folks, good luck.